Hey everyone, welcome again. So today in this video we will discuss what is breadth-first search in graph. So in previous video I have explained like what is BFS and DFS in graph. But in this video, particularly BFS in detail we will discuss, and we will discuss how to implement BFS in Java. So the program part also I will step by step explain. So before that we will just do a quick recap. So what is BFS and how we can position all those things. So suppose this is a graph, okay, and it is a directed graph because I have direction from like one vertex to another vertex. So from 0 to 1 there is a connection, and we can see from 0 to 3 I have a connection, and 3 to 0 also I have a connection. So like that way I have denoted the whole graph. Now if I am starting from a point called 0, then how in BFS we will traverse the graph, that we will see. So first I am starting from 0. So 0 is my first node here. So 0 is already visited. So then in BFS I have to maintain one visited array also. For I have to maintain a flag where we can see that which vertex I have already visited. So for that purpose we will maintain one visited flag array that will have exact same number of nodes which the graph has: 0, 1, 2, 3, 4, 5, 6. Now as I am starting from 0, that means already 0 is a visited node. Next what I have to check is who are 0's immediate neighbors, that is 3 and 1, because 0 to 3 I have a connection and 0 to 1 I have a direct connection. Then I have to traverse 3, then I have to traverse 1, means I have to maintain those things. Now I have to go to 3, the first one, and then I have to check where I can go from 3, that is 0 only. Apart from 0 I can't go anywhere else. But as 0 is already visited, that means its visited flag array in 0th position is tick marked. That means I will not take 0 as in my count. So this is the use case also, you can say, why visited flag array is maintained. Because otherwise what will happen, from 0 to 3 I will go, then 3 to 0, then again 0 to 3, then 3 to 0. Like that way I will be in an infinite loop, I will be ending up. So as 0 is already visited, then I will move to 1, and then I will check from 1 which neighbors I can go. So 1 is 2, another is 4. So I can go to, so before that 3 and 1 as I already visited, so I will mark them also. 1 also I will mark. So 0, 3, 1 I have already visited. So now I will go to 1, and from 1 I can go to 4 or 2. So we can go to 4 or 2. So then we have to mark 4 and 2 also, that 4 I have visited and 2 I have visited. Next, from 4 node 4 I have to check like where I can go. So from 4 actually there is no neighbor present, so then I will move to 2. Then I will check from 2 where I can go, that is 5. So I have to mention 5 here, and as 5 is my visited node, so I will mark it here. Then as from 2 only 5 I came, so from 5 now I have to check where I can go, that is 6. So next I have to mention 6 here, and I have to mark 6 as visited node. So from 6 actually nowhere we can go, then we have to stop it here, and this is my result for BFS traversal. So the result can vary if we are starting from any other point, okay, and from 0 also if we are starting, so we can go to 1 first, then 3 also. So then a different order will come, okay, but those all are actually BFS traversal. So now we will see in program how we can implement it. So we will implement it in Java. So before implementing this BFS with Java, so I will mention few steps actually what I am going to do. So one thing is, first I have to create a basic graph. Okay, a directed graph I have to create. So obviously I will define a Java class. There actually I will do some modification to maintain it as a graph. And here actually I will use adjacency list for representing a graph. So if you want to know like what is adjacency list or adjacency matrix, so in the eye icon I will give you the video link, so there you can go and see it. Okay, so that actually I have explained already in another video. Then what I have to do is I have to add the edges. So when the graph class will be created, so I will write a method, there we can add a edge. Okay, so suppose from connection from 1 and 2 I have to mention there, that method will take care of that. Then the third step is I have to do the actual BFS implementation. The BFS method will be there. So there actually I have to write the actual logic of BFS implementation. And inside that logic I have to maintain a visited flag, which actually I have already explained in the previous part, and a queue I have to use. So why queue is required, that I have explained in the previous video. Okay, that link also I will give in the description box. So still also I will do a recap, and I will tell you here only why queue is required. Because when I have traversed 0, so the neighbors are 3 or 1. Then next step what I am doing, I am going to 3 and checking who are 3's neighbor. Then I am going and checking who is 1's neighbor. So what I was doing is actually, so 0's neighbor I am putting into a queue. Then the first element or the first vertex I am going and checking who is that vertex immediate neighbors. Then I am moving to 1. Means first in and first out. That manner. So that's why a queue is required to maintain this part. Then I will do the actual implementation, and I will play with this visited flag and queue and implement the this BFS traversal. So now we will see, and once we are progressing we will mark it like a green color or something. Then I will come back. Okay, so coming to the implementation part of BFS, so I have created one class called graph. So now I have to create the graph structure here. So for that purpose what we have to do is I will first create a variable called v. So this private integer v means these are all number of vertices. Okay, so then what I have to do is I have to maintain one array of linked list, that is adjacency list. Okay, so if I am mentioning a linked list here of type integer, say AL, that is adjacency list. Okay, so I have to import the linked list. Okay, so graph we can define using a array of linked list, that is called adjacency list. So please watch the adjacency list and adjacency matrix video, it will be clear than that time. So it is nothing about like we will have all the nodes detail that is in array, and the list we are representing here is actually the adjacent nodes. Okay, so when I will implement it will be more clearer. Then I have to define the constructor. So the constructor will take one argument, that is integer v, that is the number of nodes or vertex. So when actually we will create the graph, that time we can mention how many vertex will be there, and that I can assign here. Okay, then when we will get the number of vertex, then what we can do is we can complete defining this adjacency list. So obviously this adjacency list will have length as v, because these many numbers of linked list I have to create inside that array. Then I can initialize them. That is integer I equal to 0, I less than equal to v, then I can do I plus plus. Then what I can do is al, suppose ith position I have to define new linked list. Okay, so each and every linked list I have to define inside that array. Okay, so I have created this adjacency list and this number of vertices. So now I have to add a method here which will add the edges. So if I define a method here, public void add edge, so that will take two parameter. One is from and another is to. So what is this from and to? That is from one node another node there is a connection present or not, that will be represented by a edge. So if I have to add a edge, then I have to go to that particular node, that is the from. Then I will, if I do AL of that from, then I will get the linked list, means the neighbors of that particular node, and I will simply add this new node there, that is 2. Okay, so this is the add edge method. So now the graph structure is ready. So I will define a main method here, and what I can do is I can initialize the graph. That will be new graph. So if I take the example which I have used when I was showing the BFS, that had actually 7 nodes from 0 to 6. So I can initialize it with 7 vertices. So whenever I am mentioning 7 here, the constructor is getting called. There it is assigning this v to this integer v, and then it is creating an array of 7 members, and all the members are actually a linked list internally. Now I have to add the edges. So here I am showing the graph actually. So the same thing I will show you here also. So the method I will call is add edge. So from will be from 0, I have a connection to 1. So I added one edge, and then I have a connection from 0 to 3, that I have added. Then I am copy and pasting. Then from 1 I have a connection to 4. Then I have a connection from 1 to 2. Then 3 to 0 also, again one connection is present. So now if you see here, I have added all the edges. Okay, now my graph is completely I have defined. Now I have to work on this graph. So our main purpose was to write the BFS algorithm. So before that we just constructed the graph. Now we will write the actual BFS method. Let's simply define it as public void BFS. Okay, so what input it will take? The BFS, the input it will take is the starting vertex. So starting vertex will be a integer that I have to pass as parameter. Okay, and when actually I want to traverse the graph in BFS manner, then I have to call these things. Suppose for our case we will traverse, means starting point will be 0. Okay. Okay. Now inside this method, the first thing we have to do is we have to define a visited array for the boolean flags. So what I will do is I will create a boolean array. Okay, new boolean, and the length of the array will be the same as the number of nodes. Now I have to define one queue. So why queue is used, I have told already. So in Java, linked list actually act as a queue. It has this poll method, which is actually dequeue. Okay, and queue dot add, if I do, then it will actually enqueue. Okay, so linked list in Java by default act as a queue. So we can simply define a linked list. Okay, so now what is the first thing we have to do? That is the adjacent nodes which I am visiting from a particular node, that I have to put it in the queue. So as it is a starting point, so for that purpose I can add this starting vertex inside the queue, and I can mark that position as true. That means this starting node is visited already. Now next time onwards, what I have to do is I have to uh, take out the value from the queue and print. Okay, so what we can do is we can mention system.out.println simply queue dot poll. Okay, and I can keep some space here where actually all those upcoming nodes I can print. Then next what I have to do is I have to check. So this value actually you can store somewhere, this queue.poll. Maybe I can use this variable itself. So there actually I can store this one. Okay, and I can print it. So starting vertex I can use this variable. Okay, because I don't have to define a new variable there. I just mentioned like queue.poll, means it will be a dequeue operation and it will be inside starting vertex, and then I can print it. Then next what I have to do is I have to find the list of adjacent nodes for that particular node. So how I can get that? I have to get that linked list. Linked list of integer el I can mention, that will be the list present in that position of the adjacency list. So suppose from 0 I am starting, then this el is actually, this linked list actually is a list of nodes which is neighbor of 0. That is in our case it is 1 and 3. So in this linked list 1 and 3 is present. Now I have to iterate on that linked list. This is the el. So I will get all this as integer I and EL. Okay, so what I have to do is I have to the new nodes, my neighbor nodes also I have to put it in a queue as I am visiting those. Queue dot add, that is I. So and I have to mark them as visited. Visited I equal to true. Okay, so that means 1 and 3 were here, that also I have added in the queue. But I have to mention one condition here, that if 1 and 3 is not visited, then only we have to insert it in the queue. So visited flag of that position, if it uh, is false, then only I have to add them into the queue and mark it as a visited. Then this whole thing from this uh, polling of that thing and printing, then getting the adjacent nodes and then looping through it and adding in the queue and mark them as visited, that whole thing I will do until and unless the queue size is 0. So if queue dot size not equal to 0, till then I will continue. Okay, so I will continue this process until this queue will be empty. So if I run through it, then I will get the BFS result. So let's run this program. So what we can see is, first it is visiting 0. Okay, one thing I can do is, instead of println, I can put a print here, then it will print side by side. Okay, so now this is my result. So 0, 1, 3, 4, 2, 5, 6. So 3 and 1 also can be present, or 2 or 4 also. So that interchange can happen. So you can go through the process and match with the graph. So this is the correct result it is showing. Okay, so this is all about a BFS algorithm, and we saw like how to define a graph and how to add a edge and how to write a BFS algorithm, and there we took help of queue and visited array to avoid this looping condition. So when we will talk about DFS algorithm, that time we don't have to define this graph from the beginning. We will just add a new method here called DFS. Okay, so that's all about this BFS technique. This programming part, this link I will put it in the description. Thanks for watching, and please mention in the comment if you have any doubt.